This is example 1 from the proofs section, and I thought I'd explain it like I would to the students. On the left here are the statements, and then on the right column there's the reasons, but I'm not going to show those to the students. So first of all, we start off like we have number 1 here, A and B are real numbers, and that's like going to meet some of your parents' friends. It's sort of a general introduction to the proof, and it's like your parents say, hey, here's Ronnie, and so we call that the hypothesis. A and B are real numbers is the hypothesis, sort of an introduction. Okay, number 2 is negative A is a real number, and that's sort of like saying, yeah, Ronnie's our son, and yes, he's in the 8th grade. So it sort of clarifies things more. And then we get to number 3, which is the start of the formal proof. And you can use like a magnifying glass with the students to illustrate that they're really being a detective and they're looking for things that are changing. What's changed in this section? So this first part here, number 3, shows the parentheses A plus B plus a negative A. And so from the left to the right, you have to look and see what has changed. We still have parentheses. We have an A and a plus and a B, but here the B and the A have switched. The plus is the same and the negative A is the same. So the thing that changed here is that A plus B became a B plus A. And then they look at their axiom sheets to look for that change. We're starting at the top, looking for something that looks like that. And here's one that looks exactly like that. This A plus B becomes B plus A. And if they just roll over, they could see that that's the commutative axiom on their axiom sheets. So that's what they would write in the reasons for space number 3. Okay, then we go on to number 4, which has nothing under here. So now we go from top to bottom, looking at these two here. What has changed between this line and this line? Notice that the B, everything's in the same position, B, A, and A, negative A. But the only thing that's changed here is the parentheses. No longer are they around the B plus A, now they're around the A plus negative A. So the parentheses have changed groupings, and then they're going to look on their axiom sheets, and like if you're walking around the room, you can say point to the one that shows that, and here it is here. This A plus B is grouped here, and then here is changed to the B plus C are grouped together. Everything else is in the same. And then they follow that over and they see that's the associative property. Okay, then we go on to what has changed from this line, and you can cross that off for the students. What has changed from this line to this line? And they notice that the B's are the same, the plus is the same, but the A plus negative A has become a 0 down here. So this part has become a 0. So what axiom shows that an A or a letter plus its negative equals a 0? And that would be right here. So the A plus negative A, and that's the axiom of additive inverses again. Okay, and then we go follow the same thing. From this line to this line, what has changed? It has a B plus 0, and it becomes a B. So B plus 0 equals B. Which one of the axioms shows there? And that would be this one here. A plus 0 equals A. So different letters, but then that's the identity axiom for addition. So that would be put over there. And then finally, we go from here to here, and we say it's the same, but they notice that, oh, here we go. They've repeated this, and they put a little therefore here. So what axiom does that? And this is the one that's probably the most confusing, so I actually write over the whole works and show them that, let's call this, because there's so much verbiage here, let's call this A if A equals B, so we'll call all of this stuff here B, and B comes down to be equaling to this one, or C, then this one is A again. Then A equals C. So that's the transitive property, and that's usually given with the therefore sign and helps the kids a little bit. Okay, let's look at example 2, and it's a little bit different properties. This one we're doing the opposite of negative A minus B is equal to A plus B, and again here are the statements. And we start off with number 1, A and B are real numbers. Again, that's the hypothesis. I'd like you to, or you could say, I'd like you to introduce my son Ronnie. And then we start off with a formal proof. And here's what's from up here. They've taken that down there, and they've started with the proofs. So from this side to this side, what has changed? So the minus and then the negative A, and the only thing that changed here is that this minus B became plus negative B. Okay, so the only thing that changed is the minus B became a plus negative B. And then that's the definition of subtraction, which is right here. They could see a minus has become a plus negative on there, and that's the definition of subtraction. Okay, then we go on to the next part. What has changed from here to here? And the minus is the same, and we're losing a brace, and we've got different here. So this is that looking for what's different is the minus puts the minus with this one, and it puts the minus with that one. So this is the property of the opposite of a sum, because again here's the sum, and it's putting the opposite sign with this one and the opposite sign with that one. So it's the so that's the property of the opposite of a sum, which is on here too, which is shown here. You've got opposite of a sum, and it places that negative with the first one and with the second one. Okay, the next one is changing. How does it change from this line to this one? And the notice that the only thing that changed is that these minuses have become a positive, and this minus has become a positive. So that's the cancellation property of opposites. And you would have the kids look through there, before you tell them though, look through and see if you can find where it shows that two minuses equal a positive. And that's listed over here, cancellation property of opposites. Okay, the last one is changing again now, where we've gone from here to here, so this repeats, and this one has stayed the same. So again, this is that transitive one where this is A, if this is A, and this is B, and B equals this, C, then A equals C. So that's the transitive one. Okay, so hopefully this will help, and again, hope that it will help for everything.